Okay, that sounds great.
And we are live. I do see the first people coming in. Welcome to this meetup. Welcome, everybody. Great to have you. We'll give this a few more minutes to let people join. If you already joined, feel free to just locate the chat. Maybe say hi. If you say hi, maybe two things. Make sure to select to everybody before posting your message. And maybe you include your location so that we get a feeling of how international the crowd will be today or tonight, depending on where you are. Tampa, Florida, Alberta, nice. Welcome, David. Welcome, Ben. Switzerland, great. Welcome, England, Boston. Nice. So yeah, make sure to select to everyone before you share a message in the chat so that everybody can read it. Otherwise, only Liz and I can read it, which is also good, but probably not as great as if everybody could read this. So Mike, you might also want to select to everyone before posting. And hi to Texas, New York City. Great. So we give this a few more minutes to allow people. Oh, Kenya, nice. Nairobi. It's been a while since I've been there, but really nice. So we give this a few more minutes to allow people to join. Maybe a few housekeeping rules. So this meeting is being recorded, as you can see. We'll share the recording with you tomorrow, together with some useful links, and also together with Liz's presentation, which I'll share as PDF. And if you have questions during this meetup, there's two options you have. You can either place them in the chat, which most of you already found, or you can place them in the Q&A section. If you do place them in the Q&A section, it's less likely that they get lost, but I monitor both. And then I make sure to transfer them to you, Liz. So if you answer them either at the end or in between, let's see how this will fit. So we're currently close to 50 attendees. So we'll probably give this another minute and then we'll kick it off. Typically, a few people will join over the next few minutes.
Yeah,
but
that
I
sounds
think
good. I'll, people can get caught up as we go along.
Yeah, absolutely.
It'll all be good.
So yeah, great to have you all here. So as I said, this meeting is being recorded. We'll share the recording with you. Maybe to introduce myself briefly, I'm Christoph. I'm working with Humanitech currently, and we are helping teams to build internal developer platforms. So we do see a lot of microservice setups, not always in the pure sense of microservices, but at least a lot of services running in parallel. And we also do see the problem of observability quite a bit. And so I'm super happy to have Liz with me today. And welcome, first of all, to this meetup. And Liz will talk about observability and self-service. I think it's going to be a great talk. So why don't you introduce yourself, Liz?
Sure. Hi, I'm Liz Fong-Jones. I'm a principal developer advocate at Honeycomb, which is a company that works in the observability tooling field. And previous to joining Honeycomb, I was a site reliability engineer and developer advocate at Honeycomb, or sorry, at Google. Sorry, brains. It's actually early in the morning for me. But yeah, I was a developer advocate at Google for the SRE community and kind of helping expand the notion of DevOps and SRE practices and helping people adopt ways of working together that would work better for cloud and microservices.
Cool. Thanks for the introduction. So I'd say we kick this off. And as I said, if you have questions in between, feel free to drop them in the chat. Floor is yours.
Awesome. So today what I wanted to talk about is how we can enable people to get better observability into their systems and to bake observability into our systems by default, so that they don't have to go through a bunch of manual pain in order to understand what's happening. Instead, we can make it self-service, make it default. So why do I care so much about observability? Like, why not something else? And the answer is that we spend a lot of time building systems. We don't necessarily think about what happens after those systems launch into production. And the statistics say that two things. Number one, that a majority of time spent on software is spent on the maintenance of the software after release. And this also shows if you survey developers and ask them, how are they spending their time during the work week? And the answer is slightly less than half of a developer's time gets spent on end-planned work, on break-fix work, rather than on kind of productively advancing features, advancing the state of the business. So we spend something like 17 hours out of every developer week on technical debt and bad code and things that did not go according to plan. And that's $300 billion per year across our entire industry. And I think that that's a giant waste, both of kind of capital and also waste of like human potential. And that if we could spend less time debugging because it were faster to debug and understand our issues, then all of us would be happier developers and we would have better software systems. But it can be really challenging to kind of balance all these priorities, right? Like you want devs to ship features faster and scale to demand and decrease downtime at the same time. And people like have said, over the past, like before DevOps came along, people were like, oh my goodness, like, I'm afraid to work in production. I just want to like land my commit and hope that another team will pick us up and, make it work after I've thrown it over the fence. They'll pick it up in a month after it passes all of the battery of QA tests and it'll work fine, right? But the reality is making it someone else's problem does not necessarily make it any easier for them. And therefore, that team can't figure out what's wrong and fix it. They escalate to you, and it's been a month, and you don't even remember what you wrote. So there are some solutions that partially work towards this, right? That if you shorten that feedback loop, if you make it easier for developers to interact with their code soon after they land it rather than a month later, then you can really kind of address some of these challenges of forgetting what you were working on. But what it does not quite address is this challenge of how do we, even if something is fresh in your mind, can you actually debug it, or do you still have to wind up pushing code and builds to production by hand while you're trying to figure out like what's going on? So that's kind of the distinction almost, I would say, between kind of DevOps, the older version of DevOps, and kind of the DevOps practices that we need that are going to sustain us into the future. Because we have microservices with complex interactions, right? When we think about the DevOps as it was practiced at Etsy in the kind of late 2000s, early 2010s, right? DevOps at Etsy was very much still focused on we are shipping the Ruby monolith, right? That powers Etsy, right? But now we have many, many, many services. So kind of those same tools that worked before to kind of give us APM views of the world don't necessarily work when we have many teams that have responsibility for many different services and that all those services talk to each other. And our failures don't exactly repeat, right? Because if we are doing our job as developers, we are obviously guarding against the things that we expect are going to fail, right? You don't deliberately ship buggy code, right? So therefore, by definition, any failure that happens in production is something you did not anticipate in advance, and therefore you may not have the right signals to debug it. And finally, we are developing more and more services that are used by more than one set of upstream users, right? That there no longer is this kind of homogeneity of workload. And instead, you can have noisy neighbors, you can kind of have all these challenges with making your services work where you can have your service go down because one customer is tickling it in a funny way, and you never would have caught that in staging, and you don't necessarily have the isolation to keep that customer separate. So all this is to say that like monitoring doesn't help us, and what we need is a new way of thinking about things. So that's kind of how I got into this field. I was a site reliability engineer at Google for over 10 years, and what I discovered was that many of the teams at Google were struggling with these same kinds of issues of how do we run large services at scale. And what I realized towards the end of my time at Google was that it wasn't just Google that was struggling with this. It was our entire industry that was either struggling or going to struggle with it as they completed cloud migrations. So I came to Honeycomb 2.5 years ago to kind of expand this mission of observability and DevOps and SRE to the entire world, to kind of help people adopt these better practices. And in the course of doing that work, I found myself working with a particular community of folks who also cared about this issue, who cared about working across company boundaries to solve these problems rather than each sitting in our silos at our own companies or with our own customers designing custom solutions. So, this is the only mention you're going to hear of Honeycomb in this talk, unless it comes up in Q&A, right? Like, in that I'm doing this in my kind of vendor neutral role as a member of the OpenTelemetry governance committee, right? I'm here to talk to you generically about observability and about how OpenTelemetry, which is a cross-vendor and cross-end user product, that can help you with some of these challenges, regardless of how you choose to store and send the data afterwards. So we're going to talk about 4 things today. We've already talked about what's painful in software development, kind of motivated you to think about this problem. Secondly, we're going to talk about defining what observability is in a little bit more detail so you can better understand whether you have good observability or not and kind of how to improve at it. Thirdly, I'll tell you a little bit about why OpenTelemetry solves these problems and what it is. And then finally, what I'm going to do is I'm going to tell you about how to get started with OpenTelemetry. So give me just 1 second because I need to, okay, there we go. And then finally, what I'm going to tell you about is how to get started with OpenTelemetry and how to actually put into practice in your org. All right, so let's go ahead and get started. Let's talk about what observability is and isn't. So as I said earlier, you have kind of these challenges of multi-tenant services. You have these challenges of services that are getting tickled by weird combinations of things that you never could have QA'd in the first place, right? You have requests that are suddenly timing out at 500 milliseconds or 5,000 milliseconds. And maybe you pushed a set of new microservices, or maybe someone downstream of you pushed a new microservice, and maybe they have different, language path settings. Maybe they have different Chrome extensions, right? And we need to be able to understand really quickly, where is this coming from and how do I make the problem stop, right? So we need instrumentation code to produce data, and then we need the ability to query that data to answer questions about our services. And the data is there to say that these practices actually do help. So you can see the evolution over the past three or 4 years of the Accelerate State of DevOps report by the folks at Dora, who brought us the Accelerate book. And they basically show that, like, over the years, we've had a shift from kind of, roughly 40 to 50% of teams being higher elite performers to, finally we've hit that curve, and now 25% of teams are able to ship multiple times per day on demand, and it takes them less than an hour to fix problems. How do they do this? Well, we now have some data to say that if you are an elite team, you are 4 times as likely to incorporate observability into your practices and to spend more of your time coding. And that if you use using open source technologies is 2.4 times as correlated if you're meeting your reliability targets, rather than designing bespoke things that are only for your specific organization. So when we think about observability, we think a lot about data, right? Like, how do we gather the data? But I think that's only a subset of the problem, right? Like, we need to think about what are we using the data for, and then figuring out what our data strategy is, right? So we need to be able to understand what's going on with our code, what's the pipeline to get it pushed to production, and how is it behaving when it interacts with real users, and what are those real users actually using it for? And can we understand kind of, do we have bottlenecks, single points of failure, circular dependencies, right? Like, those are the kinds of problems and known questions we want to be able to answer. Now, the way that we do that certainly is by having instrumentation code running inside of our app that is generating telemetry data that we're storing somewhere and then that we're querying, right? So when we talk about observability, unfortunately, there's a tendency in our industry to think a lot about, what are the technical solutions? Or, hey, is it logs, traces, and metrics, right? And the answer is that's part of the answer, but, you can have all the data in the world, but if you can't actually query it to solve your problems, you don't actually have a good solution. So, when we talk about these signal types, it's important to recognize what you're getting out of them, right? So the point of a metric is to get an aggregate subaggregate statistic, like, how many of these things were there, or what's the 95th percentile of this collection of requests. You might have diagnostic logs that contain detailed debugging information about each, request execution or each process. But to me, the thing that ties it all together is kind of context propagation and tracing, right? The idea that a request goes through many microservices, and if you can trace the flow of the request, you can derive all of the other statistics out of it. You can derive aggregate metrics. You can derive kind of the log format raw data presentation. So how do you put this all into action in a way that makes sense, rather than just have a collection of things that don't actually solve your business problem? Well, you need to have a way of generating the data, a way of sending the data, and a way of visualizing the data. So that's where OpenTelemetry comes in. So OpenTelemetry is a vendor-neutral open source framework that allows you to generate this telemetry data. So it supports tracing, context propagation, and metrics, and very soon we'll also have more fully featured support for logs, although you can kind of kludge logs into the system as is. So the idea is that instead of like using a specific vendor SDK, like the Datadog SDK or the Sentry SDK, instead you use a common SDK that is developed by the community, and then you can use that SDK to send data to anywhere you like. So it's taken us about 5 years to get here. Open Tracing, a predecessor project, was founded in 2016. And in 2018, it merged with a competing open source standard, OpenCensus, in order to form OpenTelemetry. And here we are now in 2021, where OpenTelemetry tracing and very soon metrics are generally available. So this means, what do we mean by generally available? Well, we mean that all of these things are available and working together, that there's a specification for how the instrumentation code should look and behave. There's a method of kind of collecting all this data together and then teeing it out to a variety of different syncs. That there's a mechanism for each language of actually interacting with the specification. And then finally, for any library that you care about, that you should be able to have the data automatically generated for you so that you don't have to do that work for every single function handler that you have. So the point of OpenTelemetry is to solve this problem, right? Instrumentation and data generation, but not the actual data storage at rest, nor the actual querying. So we're agnostic about how you store it. What we care about is making sure that you have the freedom and flexibility to choose a backend and then change backends without ripping out all of your code, so that you can solve all these problems at whatever scale is relevant for you. And it's meant to be a common format, right? Like that works regardless of what language you're using, or even if you're trying to send traces out of your build infrastructure, right? Where you might want to generate tracing from inside of GitHub Actions or CircleCI, where a command line tool might be the right way, rather than that's wrapping shell scripts, rather than something in a Node or Python SDK. So when we think about API design, we think about how do we make it easy to get a tracer, to use the tracer to start a trace span, and then to set various attributes on that trace span that you've created. And then after that, if you've started a trace span and then you call out to another microservice, you want that microservice to know what trace it's a part of. And we use the W3C trace context standard in order to deal with that, in order to help you get that information about what request am I a part of, and kind of what called me, so that you can pass around that detail. So that means that you can easily then extract the information out of your request handlers and kind of get that information about what's the HTTP method, what's the HTTP path, right? Like all these things get automatically appended to your instrumentation data. And then finally, you need a way to transmit the data. So one way that we do that is we go ahead and we make it possible for you to send the data using an exporter, either using the common OpenTelemetry protocol, or have a specific backend specific exporter to send that data. And if you like, instead of kind of making the decision on an app by app basis, you can just send it to a common pool of collectors in your infrastructure, right? Kind of making that notion self-service, and then have the collectors decide where to forward that data. But if you're interested in just the kind of vendor-neutral open source methods, you can do this with using Jaeger and Prometheus as your backend stores, and use OpenTelemetry protocol in order to send data to a collector, which then sends it to Jaeger or Prometheus. But it's more than just proxying. The other things that you can do are you can kind of transmute the data, right? You can send it to various syncs depending upon what kind of data it is. You can kind of take older telemetry data in the kind of open tracing format and change it to OpenTelemetry format. And you can even kind of remove and redact PII.
So yeah, Nick had a question, but I think you just answered it. He asked, can OpenTelemetry be used as a replacement for Prometheus, or do they work together nicely?
Yeah, the answer is you want Prometheus as the backend store, right? But you can use the OpenTelemetry API to generate data that you then send along to Prometheus. Or you can use existing Prometheus SDKs to generate metrics data and then send it through the OTel collector to a backend that supports OTLP, right? So that way you no longer have to worry about this, do you support, what's it called, right? Like Do you support Grafana? Do you support Wavefront? Do you support? It turns out the answer is yes. You just need to proxy it through an OTel collector first. So how do I recommend that you get started with this when you are when you're trying to get started? Well, the answer is start with automatic instrumentation, right? When you need, before you can make anything self-service, to try it out yourself, right? So measure a few tightly connected request response services, get traces out, and then start using the OTel collector to also get the system metrics and then to send the data outwards. And you can start with either Prometheus or a vendor-free tier. Yes, I do work at Honeycomb, but I also, for instance, think highly of Lightstep. You can also try Splunk. You can also try like all kinds of backends and see what works for you, because it's easy enough to just change like a couple lines of YAML and reroute that data around. But the place where you get the most insight into your code really is that place where you have custom attributes that are relevant to your business, where you're pulling out fields, right? What's the username? You don't want to send a password, right? Like that's why we don't automatically extract everything out of the post body. And then you can also create spans covering smaller units of work, right? You might have a span for a request and everything that downstream request calls, but maybe you have like a couple of function calls are expensive. Go ahead and create trace spans that you can see into where are you spending that time in the execution of your requests. And then finally, like observability data is really great then for building and layering on higher level constructs, like measuring your end user based performance and creating service level objectives based off of your traces. And then also identifying using a service map, like how do you find your single points of failure, your dependency cycles, and so forth. So that's kind of the material that I had for you kind of to start with to kind of see the conversation is, this is a little bit about what observability is. This is how you can use OpenTelemetry to get started. And what I'm particularly interested in talking about with Christoph is kind of this idea of how do we take these concepts and bake them into people's infrastructure, right? So that it's automatic, so people get it automatically and get that automatic instrumentation. Yeah, so if you're interested in hearing more, though, you can find my Twitter, and you can also I have open office hours where I meet with anyone who asks to meet with me for half an hour. So feel free to check that out.
Cool, thank you so much. We'll share this slide in the follow-up email. If you have questions, please feel free to put them down in the Q&A. I have a question because I mean, if you talk with teams about this, and probably teams that already have a very complex infrastructure, what's their biggest challenge? Like where do they fail with observability? What's your experience with that?
Yeah, people fail on observability if they try to do it all at once, right? Where they try to, before they have tangible results or anything to show, they ask people to do a bunch of painful work, and then they're like, oh, this isn't useful until you get all the system instrumented, right? So I see that most acutely when people have broken trace spans, right? Where they've instrumented, service A and service C, but not service B, right? That's why I encourage people to start small and then work your way outwards and upwards from there, rather than, doing it scattershot and saying this only works when everyone does it.
How do you deal with that across different environments? Like,
I think the way that you deal with
dev, staging, production. Sorry.
Yeah, people tend to shy away from using the same observability tools in dev and prod, and I think that's a mistake, right? I think you should use the same tooling to exercise your instrumentation in dev and in prod, rather than using disparate tools, right? That gives you exposure to what does this look like when I use it in dev, so you'll know what's anomalous when you try to examine whether it's working correctly in prod. So same tooling, maybe different data sets, right? Maybe they're slightly different data syncs, but make sure you're exercising that instrumentation from day zero, even before you're letting the code in prod. So for instance, some people will run a local Gator instance alongside their code. That way they can see the traces, even if they're developing on their local machine.
Yeah, I think that's super interesting, this end-to-end thing. And then how do you make sure that with every new service you are adding to the system, you have a default of how you do this? That's then
I think the best way is if you already have kind of common libraries that everyone's inheriting, right? If you have common libraries that everyone's inheriting, it's easy enough then to say, like you get tracing baked in by default, right?
Yeah.
And then you also need to have kind of common patterns for recognizing, right? Like if you have, if the request headers always have standardized what the user is, right? Always extract that, right? People shouldn't have to do it manually inside of each
Yeah, no, absolutely not. I'm wondering from the audience. I mean, if you wanna write in Q&A or chat, how do you? What are your challenges? What are you struggling with? Where can Liz give you an answer on how to get started? Probably because I really think this getting started thing is probably the hardest in this, because I can clearly see your point. If you try to do this top down and cover everything, it's one of these huge projects that you'll never get done.
See, what are the questions that people have? Like, please don't be shy.
Audience,
I'm here. I'm here to help.
They're all waiting for your office hour. No, so we get some questions. Thanks, Nick. So does the hotel aggregator combine logs and metrics?
Not quite yet. Logging is still in an alpha state in OpenTelemetry. We do have integration now of the, we recently integrated a logging product. I believe it's Stanza. Stanza has been introduced into the hotel collector. But I think one of the challenges is then, right, like, you know, you can then use the hotel collector to say, extract these fields and kind of pre-create metrics based off of it. If your backend is flexible enough, though, I almost would say it's better to send the raw events all the way through to your backend and let your backend handle, you know, generating metrics on the fly rather than kind of pre-aggregating the metrics. But it depends on data volume. It depends upon what your backend's capabilities are.
Absolutely. Musa is asking, can you please recommend a very basic setup example?
Yeah, so the basic setup example that I'd recommend is if you're using Java or .NET, there are agents yeah, I think it's Java and .NET. There are agents that you can turn on that will basically, without you having to modify your code, will just do bytecode manipulation and will automatically hook into your web framework, to your database framework, and start generating trace spans. So that's the simplest way to get started with kind of the instrumentation piece without writing any code, is to attach it as a debugger jar. And then once you have the data flowing, send it to an OTel collector, and then have that OTel collector route to Jaeger, right? That's kind of the simple way. Or, you know, to toot my own horn, Honeycomb does have a 20 million trace span per month free tier. So again, that's an option if you're willing to trust a third-party service, but you certainly don't have to, right? You can use Jaeger. Jaeger works fine if you're just trying to get started and visualize traces and see what you're getting out of OpenTelemetry.
Cool. Eric wants to know, any performance degradation with implementing into dev pipeline?
So I think that actually you can make your dev pipeline more responsive and faster if it's instrumented. Here's one of the cool things that we do. Let me show you what this looks like. So at Honeycomb, we use Circle CI to handle our builds. So if I go to Circle CI, I'll need to change which Circle CI org I'm in. Log in with GitHub. Okay, there we go. So I'm going to switch over to the Honeycomb GitHub. So we can see that, you know, we've got a bunch of pipelines here, right? Like this is a recent build on our main branch. And yeah, you can kind of see that there's like some stuff that happened, but it's not really clear like in what order, what was the slow thing, right? And I might want to know, how do I optimize this build pipeline to make it run faster? But the good news is that I can actually find the trace. So if I go to its build -events, check this. Oh, I got it right. Okay, cool, right? Like this is a much easier view for me to understand, where did I spend my time, right? That I spent, 64 seconds running the build, and then I spent 113 seconds running the tests. That seems like the kind of thing where I might want to parallelize running those tests so that they don't take 2 minutes. 2 minutes is a really long time to be sitting there waiting for the test to finish. Interesting, right? those are interesting realizations that we can have when we have appropriate visibility into our build system, and that speeds up our cycles rather than slowing it down, right? To be able to see that this took 13 minutes to execute, we ideally, what we would prefer is we would prefer having our builds take, less than 10 minutes, right? So I can see, let's see, I want to look at branch is main, right? And then let's look at the past 60 days. And you can kind of see that, we have some builds that fail fast. We've got some relatively slower builds, but overall it isn't creeping up over time. So I know that I can keep an eye on it, that it's not going to become an emergency, right? Being able to kind of proactively manage your build pipeline, I think that makes you faster rather than slower. And with regard to kind of that other question about dev speed, yes, tracing has some overhead, but the way that you do that at scale is you only trace 0.1% of requests. That way, at most, you're making 0.1% of requests, at most 1% slower. Like, yeah, not a big deal, right? Like that's just a wash. And it gives you far more insights about where you can decrease request time and make your app faster by slowing down a very small percentage of users by 1% to give 5%, 10%, 100% performance improvements.
Yeah, great answer. I like this visual. The fact that you can then just judge it from just looking at it and see whether it creeps up or goes down, or I think that's great to see.
Yeah. And again, I'm biased. We use Honeycomb to dog food Honeycomb. Like,
it doesn't matter what you use, but
fine.
Yeah, but to be able to see the data in that format is great. So Paris asking, how do you approach user expectations of privacy versus observability?
Yeah, that's a great question. And I think that to me, user data that's used for observability is different in a lot of ways from kind of tracking user data, right? Like, we keep that data on a session by session basis or a request by request basis to diagnose performance problems, right? That is the reason that we keep that data. So you can certainly think of ways to scrub or anonymize the data. You might not want to keep the user email if you're not running a SaaS business, right? Like, if you are running a SaaS business, you do already have written agreements with your customers, right, that say you are allowed to measure performance on a user by user basis. And they understand that the reason is to make it so that they have a fast experience, and so that if they're having a slow experience, their customer support manager can reach out to them, right? So I think it's being transparent about what is the data you're collecting, what are you going to use it for, and minimizing the data, right? Keeping only as little data as you need. And the other thing that at least we do at Honeycomb is we expire data after 60 days, right? That is our threshold between, what is the data that we need to diagnose performance regressions over time versus at what point is it a liability to keep that data sitting around, right? When we are not going to look at it, right? You may as well throw it out at that point.
Great. So here we have it. What does Honeycomb do? Is it an incident center?
Yeah, so, I didn't want to get super vendory here, but Honeycomb is one of many potential places that you can choose to send your telemetry data to. And then it allows you to interact with that data as traces or as metrics or as individual events, right? It lets you visualize and understand what's happening in your production services and debugging. But there are competing products, like Lightstep, like Splunk, that you can also use, or like New Relic, which is actually the next question, right? Like,
yeah, which is a great question. Yeah.
Right, like, is that there are many different solutions that can do these kinds of things, and it's just a matter of your taste, right? So we want it to be easy for you to switch between these things. And
I think the next question is a great one. So yeah.
Yes, you can use it to debug incidents, but I think it's much more powerful if you use it even to avert incidents, right? To understand the performance of your system before it becomes an incident.
Yeah, absolutely. Next question is I think great. We are already using New Relic. We would essentially have to backtrack and retrofit OpenTelemetry into our system, or to utilize it, or how would you make a switch from a vendor specific SDK to OpenTelemetry?
Yeah, I think that if you're already happy with your vendor, I would say there's not necessarily a reason to switch. But if you are looking at changing vendors anyways, you're going to have to instrument a new SDK because your old vendor's SDK is not going to work, right? At that point, you may as well adopt OpenTelemetry, right? And that gives you freedom and flexibility, right? The business case is that it gives you vendor neutrality and independence, which means that you might be able to negotiate better terms with your vendors compared to if you're locked into them, right? And I think that the other thing is that at least I know that New Relic is a major participant in the OpenTelemetry ecosystem, right? Like they want to make your life easier with OpenTelemetry, even if you are using some bits of New Relic proprietary SDK. You can still write, OpenTelemetry code and have it interoperate with your New Relic code, right? Like that's kind of one of the things that they've been working towards, right? Like everyone who's a participant in the project, whether they be, New Relic, Splunk, Honeycomb, Datadog, right? Like we all want you to be successful because at the end of the day, none of us want to be maintaining all of these, 100 different integrations with Express, with Node.js, with like, all these varying technologies. We'd rather just have one set of SDKs to interact with any of us and therefore have less maintenance load over time. So all of us are working towards how do we deprecate our older vendor-specific SDKs.
And how do you
So you don't have to backtrack and retrofit, but like it also is a smart decision if you do.
Yeah. I think you already answered Alex's question, which is, would you recommend moving from OpenTelemetry and why yes, no? I think you just,
Well, yeah, I think, it depends. If you're instrumenting new stuff, certainly OpenTelemetry metrics SDK is a compelling option. But, if you're already happy with Prometheus, like, keep using Prometheus. We can still ingest it via the OTel collector.
Yeah. I think the next question is great. How would you set about changing the mindset of the engineering team leadership around adopting the observability mindset? I'm at the beginning of trying to influence them down the path of thinking around observability. How would you do that? How would you convince your leadership?
Yeah, I think the thing to point to is the key business metrics that your engineering team is trying to achieve, right? Are you trying to achieve shipping features faster? Are you trying to achieve higher reliability? What's holding you back from achieving those objectives? Are you spending, 17 out of every 40 hours firefighting, right? If so, you can kind of make that case then to say, if we had better observability, we would spend, 10 hours per week and not 17 hours per week firefighting, right? Think about what we do with those extra 7 hours. So I think when you point to the things that you can't do with monitoring that you can do with observability, that kind of opens people's eyes, right? When you tell people, hey, did you know that if you had observability, right, if you were using tracing, if you're using OpenTelemetry, and a suitable backend, that you could break down by user, right? That you wouldn't just have this mystery spike of latency that you have no idea where it's coming from. You'd be able to tell exactly what user is having that problem, right? And exactly why based on the traces. So I think, show them a demo of what it looks like to have good observability, on someone else's app, even if it's not your own app. Or OpenTelemetry does make it relatively easy to kind of at least collect rudimentary traces that might give you value on day 0. Just run a proof of concept experiment, maybe even in your staging environment if you don't want to trust anyone with your personally identifying data.
Yeah, and start small. I like that idea that you brought up earlier. So the user is asking, how do you manage observability outside of working hours for teams that don't do weekend night guards? Who's in charge of observing in case of outage?
Yeah, I think that relates to the DevOps shift, right? Like we're shifting more towards production ownership. We're shifting more towards having development teams be responsible for their code, including out of hours. That doesn't mean making them miserable outside working hours, right? Yes, there is a thing where ops teams, those of us who have worked ops for, a decade and a half, we can deal with being paid at all hours, but it doesn't mean that we like it. And we don't want to inflict that on anyone else, right? So you want to give teams the appropriate tools like observability to manage being on call and to manage so that they have fewer escalations overnight, as well as to debug those escalations more quickly overnight, right? So when you shift towards production ownership, that causes this virtuous feedback cycle if and only if your service is already manageable enough that people are willing to be on call out of hours for it, who are not ops engineers. So, right, like that's kind of been the challenge. Is the older way of DevOps had, this is the APM tool that we automatically apply to everything that we deploy, right? And it's a separate ops team that knows how to manage the APM tool, right? Like, whereas the idea with observability is the same team that is writing the instrumentation, adding these attributes, also is looking at them after it goes out, right?
Yeah.
At Honeycomb, we're very famous for this, for championing the idea of, yes, it is safe to deploy on Fridays. What is not safe to do is deploy it on any day of the week at 6 p.m. and walk away from your computer, right? The rule is, if you're merging code to main, it's going to go out within an hour. Stick around for an hour or two after you merge a commit so you can watch it go out live, right? That is our sense of production ownership. That's how we manage kind of that incentive of ensuring people are incentivized to have appropriate observability. Is you are responsible for your code, at least for the hour or two after it reaches production. So, yes to Friday, 3 p.m. deploy, no to, even Monday or Tuesday, 6 p.m. deploy.
Understood. Great. The question, is there a good way to test my observability code? For example, I use Terraform to create quite sophisticated monitors on Datadog, but never figure out how to test them. When my monitors are silent, I don't know if the system is running well or if it's the monitor that is misconfigured.
Yeah, that's a great question. So my answer to that is, with OpenTelemetry, you can pass in a mock SDK. You can pass, OpenTelemetry has the idea of a version of the SDK that is a locally testable version. So you can verify that a trace span was created with the attributes that you expect. So I think that is probably the best way, is to treat OpenTelemetry as something that you mock, right? And we provide good support for doing that. So you can verify that the telemetry data that you're emitting is in fact the telemetry data that you expect. And then, right, like, your tests are not necessarily going to be sufficient, right? As you are working with your code and poking at it via manual testing in your local environment. Make sure you're actually sending that instrumentation data to maybe a local Jaeger, maybe to a separate dev data set in your cloud, in your SaaS service, right? Send it somewhere and look at it so that you know what to expect, because you're going to have to look at that in production with the real user data coming in. So you may as well know what it looks like in dev, and maybe you'll realize, hey, it would be handy to have this attribute. Let's add in this attribute, right? And you'll learn things about what your instrumentation code should be. Yeah, I think the other thing is, when you talk about instrumentation data, it's also about what you do with it. What are the insights, right? So I think it is helpful, definitely, for sure, to have some monitors and kind of threshold alerts, but the better approach is service level objectives. The better approach is to say, how am I going to measure this end-to-end user workflow? What are those trace spans going to look like in event of failure? Can I identify when there's a pattern of failing trace spans, right? And to highlight that. So I think that's better than having kind of more and more sophisticated monitors, and many of them, right? You're going to have all those like flapping at random hours. It's better to focus on like 1 or 2 high quality user facing metrics that are derived from your traces than to have many, spaghetti code data rules.
Cool, thanks. And I like the idea of transporting this from your local dev environment all the way to production, so that you know what to expect. I think that's, you mentioned that earlier, but I think
but you have to make it easy to do in your org, right? Like,
yes.
People should not have to be observability experts. Yes, those of you who are here, congratulations, you know a lot more about observability than your colleagues do. Now, kind of, how do you both spread the knowledge within your org and also make it so that other people don't have to learn all of this stuff, right? They can just get started and see traces from day zero, right? Like, anyone who starts should be able to say, here's the button to click to go and like explore that trace data that's automatically created for your brand new service.
Yeah, and that's probably also, there's a last question from Matthew. Is it possible to deploy as a daemon set operator on Kubernetes to auto debug applications and to avoid instrumenting per application?
Yes, there are 2 ways to do this. One of which is, I mentioned the kind of Java and .NET and JavaScript auto instrumentation, right, where you attach it as an agent and it will automatically deploy. The problem is not every language is going to have support for that, right? Like in Golang, we are notorious about being type safe and about not allowing monkey patching, right? Like, so you're going to have to do some work to manually to add in the auto instrumentation, right? To say, hey, Gorilla Mux, here is a thing to call before and after each event handler, right? You can't automatically do that. You kind of have to hook it up. But if you're interested in something that's even more hands-free than that, there are a couple of options. One of which is we have recently added some degree of support for eBPF, the extended Berkeley packet filter mechanism, to do kind of kernel level sampling of where it, which requests are executing, which section of the function are they executing in right now. And that requires zero instrumentation. It does require you to have source maps on file to kind of map the individual, memory, assembly instructions into which line of code does it translate to. What that doesn't currently give you is request by request visibility, only whole application visibility into kind of what are the hotspots in your code. So that's one option that we're currently working on in OpenTelemetry, but the support in the backends is a little bit more spotty for it. The other option is service mesh layer, right? So as a daemon set or as an operator, in addition to deploying the OpenTelemetry agents and collectors on attached to each pod, if you are using a service mesh like Istio, you can basically say, hey, I want requests that are coming in and out via Istio to automatically generate trace bands and to send those trace bands using, in this case, Istio, I believe, is open tracing, but not OTel yet. It's a thing they're working on, where you can emit open tracing format from Istio, send that to an OpenTelemetry collector, which will then transmute it to OpenTelemetry. And then you can send OpenTelemetry protocol to any backend.
Cool. Thanks. So great questions. Thanks for asking. And I think watching the chat, you got thumbs up for your answers, Liz. Great. So thanks again for.
Yeah, I'm really curious what people are going to take away from this, and kind of if you want to type in the chat what you're going to do, like after having heard this talk, I'd be very curious to hear your answers.
What's your next step tomorrow morning, or today if it's morning for you? What are you going to do? Detailed look at the SDKs. Yeah, it's a good first step.
Yeah, the SDK and API documentation is very helpful if you're trying to understand, like, what are some working examples of this? How do I get started?
My takeaway is to give you a follow on Twitter list. Great, that's good. Talk with my colleagues. Yeah, cool. Yeah, we sent the recording. Yes, replace Datadog. Well, if you're early, that's probably still a thing to do to avoid the vendor login.
Yes, yeah. The highest effort to impact ratio is definitely like tracing your deployment pipeline. Like that will save you minutes per build. Like it's seriously good. Like and it costs next to nothing because your trace spans, you'll send like maybe 10 trace spans per build execution. Like it's nothing.
Okay, cool. So I hope you can put this into action in your next working day or even today. As I said, I share the presentation with all the useful links. This has an open office hour, as I learned, also an option to keep in touch. And so, yeah, thanks for joining. Thanks for being in this meetup and sharing your thoughts and knowledge about observability. It was great. So see you all next time, I'd say. Have a great day.
Cheers. Thanks for joining.
Bye.